Do you know Mary Elizabeth Winstead? No? Shame. She is the most beautiful woman ever lived. Well, at least for us. The expression of her aesthetically pleasing genes are the reason why we found her brown eyes mesmerizing and her brunette hair captivating. On top of that, she's been dubbed as one of the most kindest actresses in Hollywood. Can you believe that? A beauty with a heart. You've got to be kidding me, right? The world is unfair enough as it is. We all should blame her genes for that. But no, it wasn't just genes. In the field of psychology, where nature, the biological foundations of why we behave, and the nurture, the environmental variables that impacts who we are, still remains a controversy that dominates the question on why a person behaves and are built the way they do. A new emerging field of science, namely epigenetics, explains the analysis of factors that decides how much of an individual's genes will be expressed in the body. To make it clearer, I want you to meet Mary and Maria. Sisters? Well, technically yes, but to be exact, they are identical twins. And of course, their genes are identical too. Mary and Maria were separated immediately at birth and lived in a completely different environment. As a baby, they may share the same genes for height, but if one doesn't receive the same amount of nutrients and lacking exercise, then their height might differ one another. The same goes for their other traits. Fast forward, Mary grew up as an ideal student, having good grades, becoming a student council president, a total achiever, and on top of that, a very kind person. Maria, on the other hand, became a school delinquent with unsatisfactory grades, bad school record with charges of vandalism and drinking alcohol. Mary cares for her well-being. She's exposed with a well-balanced diet, a regular exercise, and in her adulthood, she's likely the one who will make it her hobby to do a daily jog and even add more activities in between. While Maria, who is much exposed to smoking, junk foods, and alcohol, is more likely to have a higher risk of having health complications. Even though they're identical twins who share identical genes, being exposed to a completely different environment, differences are inevitable. Changes are bound to be seen. This is where epigenetics slide through. Epigenetics doesn't change our DNA. Our DNA isn't modified at all. Well, at least not on a sequence level. But rather, it changes how our body reads our DNA. Special marks, namely chemical tags, are added or removed caused by our environmental factors that changes how a protein works in the body. That basically controls the expression of our genes. But how does it work exactly? Firstly, our body is composed of cells, the basic unit of all living organisms. And every cell in our body contains DNA that serves as a blueprint for building a body. A small distinct portion in those DNA is what you call genes. Genes in DNA are expressed when they're read and transcribed into RNA, which is translated into proteins by structures called ribosomes. The proteins are what determines a cell's characteristics and function. Epigenetic changes determines whether a gene should be expressed or silenced by interfering with the transcription. The most common way of interference happens when the proteins wrapped around the DNA gets labeled with small chemical tags that turns the genes on and off. These chemical tags can be influenced by factors including diet, chemical exposure, and medication, basically by environmental factors that the person experiences in their course of life. Still confused? Imagine this. Our DNA is like a recipe book containing different ingredients called genes. These chemical tags we acquire through our environment tells the RNA how to use this recipe. RNA reads the DNA like a chef reading a recipe that helps assemble proteins. Going back to the example earlier, Maria having an unhealthy lifestyle could trigger an epigenetic change and can turn off or silence a specific gene trait like tumor-suppressing genes. By now I know what you're thinking. Epigenetics is revolutionary. I know, right? Especially for the future of medicine. How so? Well, let's talk about one of the leading causes of death around the world. Cancer. Cancer is defined as an uncontrolled growth of cells with a metastatic potential.
meaning there is transmission of pathogenic microorganisms or the cancerous cells from an original site to one or more sites elsewhere in the body, usually through blood vessels or lymphatics. In today's medicine, we use chemotherapy to deal with these cancer cells, depending on what the cancer a person has or how far along it is. But most times, cancers are detected late. And by this time, chemotherapy can't cure or control the spread of cancer and is simply used to shrink tumors that cause pain or pressure. And upon doing this a couple times, other cancer cells come back with more resistance to the previous treatments, causing these tumors to grow back. But with epigenetics, the potential of chemotherapy and other cancer treatments could put an end to the rising cases of cancer by providing ways to remove bad epigenetic marks and add good ones. Due to the epigenetic therapy, the cancer cells are becoming more normal, therefore weakening its defense system that paved way for the immune therapy to strengthen the immune system. This provided power for the immune system to detect and eradicate the remaining cancer cells in the body. Genetics is somehow fixed in itself, but with epigenetics, we have the power to cure diseases caused by our epigenetic changes. It offers a basis of understanding how experiences and environment affects the expression of genes to create individual variations in actions, perceptions, behavior, and psychological health. Going back to Mary and Maria, environmentally induced epigenetic changes are a part of the reason why genetically identical twins can grow up to have very different lives. As twins get older, their epigenomes diverge, affecting the way they age and their susceptibility to disease. Bottom line, we can't solely blame genetics for our future diseases. The way we live our lives is partly to blame. Why? A balanced lifestyle that includes a healthy diet, exercise, and avoiding exposure to contaminants may in the long run create a healthy epigenome. In the same sense, genetic alone isn't responsible for how and why the person behaves the way they do. The experiences, the environment they lived in bears a similar responsibility, proving that both nature and nurture contributes to the person who we are today.